All right, guys, for today's warm-up, we're going to be graphing the cosine function, but we're going to be looking at it from a different interval. So let's do a quick review from yesterday's material. So if you remember cosine, the pattern for cosine is it starts at +1, and its pattern, it goes down to 0, and then to -1, and then to 0, and then back up to +1. So cosine oscillates between +1 and -1. Now, if we were to label this in degrees, but let's try and label it in radians since it wants it in radians. So if we label it in radians, the first unit, of course, is 0, but the next unit is going to be pi/2 because that's the same thing as 90 degrees. The next unit would be pi, that's the same thing as 180 degrees. The third unit would be 3pi/2 because that's the same thing as 270 degrees. And the last unit would be 2pi because that would be 1 full revolution or 360 degrees. Remember, the period of cosine is 360 degrees. So every 360 degrees or every 2pi, it's repeating itself. So even though that's a great graph, it's not what this question wants. It wants between -7pi/2 and -3pi/2. Those are the two values it wants. Now, if you look at the x values, you'll notice that there's a pattern going on. You notice it's 1pi/2, then skip 1, then 3pi/2. If you skip 1 again, it assumes to reason that the next line is going to be 5pi/2. And then if you skip again, the next line would be 7pi/2. So that's the pattern for helping us label the x coordinates axis. And so let's go backwards now. So we're at 0. So if we go backwards, the first unit to the left would be -pi/2. And then skip a hash, and then you'll have -3pi/2, which is what we want for our right boundary. So then if we skip again, another hash, we'll have -5pi/2. And if we skip another hash one more time, we'll get -7pi/2, which is the left side boundary that we want for this problem. So now all we need to do is just finish the pattern. So remember, cosine starts at 1. So if we go backwards to the left, then cosine's pattern would go to 0, and then -1, and then 0, and then +1, and then 0, and then -1, and then back to 0. And if you graph all of that, that would be the cosine graph. But just keep in mind that on the test, it just wants this interval. And so that would just be in yellow right there. And that would technically be the answer. But if you're anything like me, I have to graph the whole thing out so I can see the picture. But that's the answer for the warm-up. All right, so now let's talk about the essential question. Now, yesterday we talked about positive sine and positive cosine. So your essential question for today is, what are the graphs of negative sine and negative cosine? So let's just go ahead and jump right into this and maybe review a little bit about, let's start off with positive sine. Let's review a little bit with positive sine. So if you notice, I've got two axes here. So let's graph positive sine on the top axis. So positive sine starts at 0, and its pattern goes up to 1, and then goes back to 0, then to -1, then back to 0. So you could do that in radians or degrees, it doesn't really matter, but just know that it goes to a maximum of 1 and a minimum of -1. It oscillates between those two values. Well, here's the difference with negative sine. If you can imagine positive sine as having an understood coefficient of 1 in front of it, think of negative sine as having a -1 coefficient in front of it. So what we're going to do is let's take each of the values that we got for sine and just simply multiply it by -1. Well, since sine starts at 0, 0 times -1 will still be 0. So negative sine still starts at 0 just like sine. But here's the difference. Positive sine goes up to 1. So if we take that number and multiply it by -1, we'll get -1. So there's the difference. Negative sine starts at 0, but it doesn't go up. It goes down. Now the pattern remains. So it goes from 0 to -1, then back to 0, then up to 1, and then back down to 0. And so that's the pattern for negative sine. Now, a very interesting thing happens visually if you can see it. Let's see what would it look like if you put both of these graphs on the same chart. So if you put that negative sine graph on the same chart as the positive sine, you'll notice that if you were to add those two functions together, blue and orange, really, Miss Thomas, gator colors,
I'm sorry.
So you add those together and you get 0, which is pretty much what they score on Saturdays.
Oh, that's pretty good.
Anyway, all right, so that's it for positive and negative sine. Now let's go ahead and go to negative cosine.
Go Kentucky.
Mm-hmm. That's why she didn't use red and black. You can see that because she didn't want that total to be 0.
True.
All right, so let's review positive cosine. Now, if you remember positive cosine, its pattern, what you do is it starts up at positive 1. And so positive cosine, and again, if you could just think about the positive cosine having an understood coefficient of positive 1 in front of it. But its pattern, it starts up at positive 1, and then it goes down to 0, and then goes down to negative 1, then back to 0, and then up to positive 1. Now, again, it doesn't matter. We didn't label them with degrees or radians because you could label either or, but just know that the points are 1, 0, negative 1, 0, and 1, because that's really just the pattern that you've got to catch on to. Now, negative cosine, if you can imagine, think of it having a negative 1 out in front as the lead coefficient for the cosine. So let's take each of those values that we got for cosine and multiply them by negative 1. So since positive cosine starts at positive 1, if we take that and multiply it by negative 1, we would get negative 1. So negative cosine doesn't start at 1. Negative cosine starts at negative 1. And then it just follows the pattern negative 1, then 0, then 1, then 0, and then negative 1. And again, you can get those values by taking each of the positive cosine values and just simply multiplying them by negative 1. And you'll get negative 1, 0, 1, 0, and negative 1. Again, just like before, we could take those two graphs and put them on the same axes. And if you label those, you'll notice that the pink is positive cosine, the green is negative cosine. And again, if you were to add the pink and the green graphs together, they would total to be 0. In other words, they would cancel each other out, and that would just be 0. And so the main thing for today's lesson is making sure you know the patterns for positive sine, positive cosine, negative sine, and negative cosine. All right, that's it for today's lesson. Have a good day.